make my recommendation on what points to use. You guys noticed the 1/3, right? I would plug in values that are divisible by 3 or 0, right? Because 0 is a really good number to plug in the first place. So let's make our chart. I want 3 values, okay? And you'll be required to have 3 values on the assessment, okay? So our first section of the chart, wow, what's happening? Hold on. There we go. Our first section of the chart are going to be my x values. Then I'm going to have my f of x values. And then I'm going to put them in as a coordinate, x comma f of x. Is this still scented? Yeah. Okay. So, what x values should I use? I definitely want to use 0. David? 3 is one of them. And -3, okay? These are the values I would recommend you use because then you're not going to have to deal with fractions because you're dividing by 3 during the problem. Let's plug in -3. Who wants to plug in -3 for me? Karen? Mm-hmm. Mm-hmm. Uh-huh. It'd be 9. -1/3 times 9. Very good.
And then you have to multiply, so it'd be -9/3.
Mm-hmm.
Simplifies to -3.
Which is -3. Very good.
-3 plus 2 is -1, so it'd be -3 comma -1.
-3 comma -1 is my first point. Very good, Karen. -3, -1. Let's go ahead and put that on our graph. -3, -1. All right, let's plug in 0. Who can walk me through 0? Matthew?
Alright, so you plug it in, which gives you -1/3, parentheses 0, and to the power of 2,
Mm-hmm.
plus 2.
Yep.
And then, you divide it, which it becomes 0.
Yep, so it's going to be 0. Bless you.
Yeah.
0 squared.
Yeah, 0 squared.
What's 0 squared? What's 0 squared? That's for the whole class. What's 0 squared? 0 times 0 is 1?
0.
Wait, what's 0 times 0?
0.
What's 0 times anything? 0. So 0 squared is 0, and then 0 times 1/3 is still 0. So we have 0 plus 2. What's 0 plus 2? 2. So my next point is at 0, comma 2. Okay? Matthew, where's 0, comma 2?
On the 2.
On which axis?
1.
On the y-axis. Very good. On the 2, on the y-axis. And then let's plug in 3. David, can you do 3 for me, please?
We got f of 3 and it equals -1/3 parentheses 3 squared plus 2.
Mm-hmm.
They give 3 squared to give you 9.
Mm-hmm.
And then you do -1/3 out of 9. Give you -9/3. And then you divide by 3. It'll give you a -3
Mm-hmm.
plus 2.
Yep.
Give you 1.
Not 1.
-1.
There you go. -1. All right. What's your point? 3, comma -1. And when I put that point on there, 3, comma -1, how is my parabola going to look?
Like a triangle.
Like a triangle? This is what my parabola looks like? How should I draw my parabola? It's going to be curved. Which way is it facing?
Down.
Down. How did I know before I started this problem that this parabola was going to be facing down? Matthew?
Because the 1/3 had a negative.
Excellent. This negative indicated that my parabola was going to be facing down. Would you guys agree, isn't it a bit wider than what we're used to with our standard parabola? Why did it get wider? David? What?
+2.
Not the +2. That's a different transformation. It is a transformation, though. You are correct. But what transformation? Why did it shrink? Because of the 1/3. Remember, when that a value is smaller than 1, right? When its absolute value is smaller than 1, it's going to shrink your graph. It's going to make it wider, okay? It's going to make it more wide, right? More bowl-shaped. And then lastly, why is it shifted 2 units up? David, that's because of the +2, okay? So as soon as you're done graphing your chart, go back and be like, okay, what transformations actually happened here? And do they match what I graphed on my graph, okay? Go ahead, Caden. What questions do we have on this example?
For the test, are we gonna have to write all the transformations?
Yes. Would you like me to write them out for this one? Okay. So the negative was what? What did that negative sign do? Not a shrink. Yeah, it made it flip upside down, right? What do we call that? What transformation? It's a reflection. Very good. So there was a reflection. Okay. Now we move on to the 1/3. What was the 1/3 doing? I think Austin said that one.
Shrinking.
It was a shrink. Very good, Mia. And I always say by what factor? So it's a shrink by what? By 1/3, right? Don't include the negative. The negative is a separate transformation. Remember, the negative was our reflection. You got that? The shrink was by 1/3, okay? And what was the last transformation, Colin? Trans what? Translation, aka a shift, right? You can use either of those words. It's a shift where, Colin? Up to. Why up to? Is +2, okay? Because it's +2.
Why is it not to the right too?
Why is it not to the right too? It's a vertical reflection. Remember, Mia,
Negative though?
what?
Isn't it negative?
The 2? No, the 2 is a positive. The 2 is being added.
Oh, I'm sorry.
If it was negative though, it would be down. For left or right, Mia, that would have to be x + 2 squared. It would have to be inside the parentheses. We won't see that, Mia, until one of the later chapters, or sections, excuse me, okay? Good questions. Any other questions on the warm-up? Okay, let's pull out our homework from yesterday. Let's go over that. We are now adding in what term? BX. So do you guys remember when we were factoring, I was like, you're going to have an A, you're going to have a B, you're going to have a C? We left out B this entire time. 8.3 involves that B value. Now, before we only talked about vertical like shifts, correct? It could only move up or down. When you add in that B value, you end up shifting your graph to the left or to the right, okay? Now, it is not a direct shift. So if your B value is 2, that does not mean that you shift to the right 2, okay? It's related by this ratio, -b over 2a. And the most important part of today's lesson is this guy right here. You definitely want to circle him, okay? Your axis of symmetry is going to be x equals -b over 2a, where b is that value that's next to your x term, and a is that value that's next to your x squared term, okay? So your a value comes from here, your b value comes from here. All right, now some things I want to point out to you. When that a value was positive, right, what did our parabola look like? Was it a U or was it an N?
U.
It was a U, okay? Write that in there. When our a value became negative, when it was less than 0, was it a U or was it an N? It was an N, okay? It opened down, okay? Remember, that still applies even with that random b value being added in there. Now our y-intercept is our c value. So whatever that value at the end is, that c value at the end of your quadratic, you're going to put 0, c is going to be a point on your graph, okay? That is going to be your y-intercept. The x-coordinate of your vertex, aka your axis of symmetry, is this golden ratio, negative b over 2a. And I want you to circle both of them in there. It's super, super important. That's probably the most important thing of all of today's lesson, is that negative b over 2a. Okay, so the first part of today's lesson is we're just going to use that ratio, and we're going to find both the axis of symmetry and the vertex of these functions without graphing them. So before, right, I would give you a parabola and be like, where's the axis of symmetry? Where's the vertex? And you'd find the vertex by looking at the graph, correct? What if you're not given a graph, right? So what we're going to use is we're going to use that ratio. So we're going to write AOS for axis of symmetry. And our ratio is going to be x equals negative b over 2a. Yes.
To unlock the curve type.
Okay, take out a paper and pencil. All right, so
Is that 2A?
that is 2a, correct. Now, we have to go back. Addison, what's up?
Can I use one?
Yes, you may. Set a timer, please. What are my a, b, and c values for this function? A is 2. B is positive 8.
C is negative 1.
C is negative 1. So now plug in your b and your a. This is going to be x equals negative what? 8 over 2 times 2. Pause. Does everyone see what I did here?
Yes.
Talk to me if you don't. You got it?
I got lost up on the curve.
What happened, David? What's confusing you? Talk to me.
Oh, I got it.
We got it?
Yeah.
Okay. Now it just becomes a matter of solving this fraction. What is 2 times 2?
4.
Okay, so what's negative 8 divided by 4?
4 negative 2.
What?
I mean negative 2.
It's negative 2. So guess what I just found? The axis of symmetry is x equals negative 2
So this lesson is finding the axis of symmetry.
without a graph. Now, hold on. There were two things being asked for us. It wanted the axis of symmetry and the vertex. So, remember, does our vertex always lie on the axis of symmetry?
No.
Does our vertex always lie on the axis of symmetry? Yes, because the axis of symmetry is the vertical line that goes through your vertex, correct? Now, when you have the axis of symmetry, we're going to use that and plug it into our original function, and that will give us the y-coordinate of our vertex. So watch, we're going to take this negative 2, and we're going to plug it in for x in our original function. So we're going to say f of negative 2 equals 2 times what? Negative 2 squared plus 8 times negative 2 minus 1.
Got you. There's a lot going on.
There is a lot going on, but it gets really simple once we start to use our order of operations. What do I do first here, peeps? Okay, parentheses, but is there anything to solve inside the parentheses?
Exponent.
No, there's nothing inside the parentheses, so then we move on to exponents. Very good. What exponent do I evaluate? Negative 2 squared. What's negative 2 squared? So it's going to be 2 times 4 plus 8 times negative 2 minus 1.
Wait, where'd you get the first two? Oh, 2 times.
Yeah, I got the first 2, Mia, from up here. I'm just plugging into my original function.
Now we do
Okay? You guys with me? All right, what comes next? 2 times 4, which is 8. What else?
plus 8 times negative 2.
What is 8 times negative 2?
Negative 16.
Negative 16, and then I still have a minus 1.
So we have a
What do I do now?
16 plus 8.
Combine the like terms. Very good. What's 8 minus 16?
Negative 8.
And what's negative 8 minus 1?
Negative 9.
So guess what? Who thinks they know both the x and the y values of my coordinate? Matthew?
Negative 9 is y.
You're right, yeah.
And then negative 2 is x.
Thank you. Negative 2, comma, negative 9. Look at it again. This is my AOS. Axis of symmetry. This is my vertex. Where'd the negative 9 come from? Mia, that negative 9 came from when I plugged in negative 2 for my x value in my function. What?
I look at it.
You don't get it? So, were you with me when I was plugging in the negative 2?
Yeah.
When I simplified this right-hand side, Mia, it just turned out to be negative 9.
Oh.
So then I knew that my negative 9 was my y value in my final answer for my vertex.
Okay.
Does that make more sense? Are you sure? Yeah. Okay. What other questions do we have, guys? All right. We're going to do B now. Should we freak out because one of our terms is missing?
Yes.
Yes?
Yes.
Oh, sure. Go for it. Let's see how you do on the test when you freak out. Okay. So let's identify our A, B, and our C. Alfonso, what's my A value? What's my B value? What's my C value? No. Can I write C equals nothing, Alfonso? What do I do? It's 0. Very good. Okay. Whenever a term is missing, the coefficient there or the number is 0. Okay. So my C value is equal to 0. Now I'm going to go ahead and get started. My axis of symmetry. Who has the formula memorized? Karen?
Is it negative b over 2a?
You're so good. Okay, negative b over 2a. Someone else plug these values in and tell me what I get.
Wait, I have a question.
Yeah, Salucci.
When you plug in the negative 2 to the b, does it stay negative? Or does it
Ah,
cancel out?
good question. Let's walk through this one. So it's going to be negative, and you agree, Michael, we're plugging in a negative 2? So isn't it going to be negative 2? Ah, it becomes positive 2. Very good. But we're plugging in negative 2 over 2 times 3. So, negative 2, Michael already said that's going to be positive 2 over, what's 2 times 3, peeps? 6. Guys, a common mistake. Does this give me 3?
No.
What does it give me?
1 over 3?
1 over 3. Okay? Again, another moment for learning. Are we going to freak out because our axis of symmetry is a fraction? No. X equals 1 over 3. It makes you nervous? That's okay. All right, so we're good on axis of symmetry. We're halfway done. Now we also have to find what? The vertex, okay? Your y value of your vertex. So we're going to take this 1/3 and plug it back in like David said. So it's going to be f of 1/3 equals 3 times 1/3 squared minus 2 times 1/3.
Uh-oh, no, we gotta do first though.
What do we do first, David?
We do the exponent.
Very good.
1/3
So
squared.
evaluate that exponent. F of 1/3
1 over 9.
equals 3 times 1 over 9. Very good.
I'm on fire. Let me
Minus 2 times 1/3. Now that we've evaluated our exponents, can I go ahead and multiply?
Yeah.
Sure. What's 3 times 1 over 9? It's going to be 3 over 9, right?
Yes, yes.
Minus, what's 2 times 1 over 3? 2 over 3. Do you guys agree?
Yes.
Can we subtract these the way that they are? Why not?
They don't have like denominators.
They don't have a common denominator. Can you simplify one of the fractions, though?
Yes, we can.
Caden? 3/9 simplifies to what? You're so good. 1 over 3 minus 2 over 3. Now can we subtract these
Yes, we
fractions?
can, mister.
Bingo. They've got a common denominator of 3. What's 1 minus 2? It's not 1. It's negative 1 over 3. All right, someone put it all together for me and tell me what my vertex is. Caden? Negative 1 over 3, comma, negative 1 over 3? No.
Can I get you right?
Thank you, Salucci. It's a positive 1/3 and then a negative 1/3. Talk to me.
What you want me to tell you?
Talk to me.
Alright, I'm talking to you.
It's not bad? Okay, let's see how not bad it is. Try C on the next page on your own. No fraction, just a standard axis of symmetry and a vertex. Alec, what's up? So, vertex should have been -3, -4. Okay? I need someone to walk me through getting the axis of symmetry first. David, go for it.
I want you to make the
You want to do the vertex? Salucci, can you do axis of symmetry for me, please?
Okay, so to start, I plugged in the -b over 2a, and I got -6 over 2 parentheses x. Then I simplified it to -6
Wait.
over 2x.
2x.
Up to 1, I plugged in.
Oh, yes. The a value is 1. Correct. Okay.
And then I got -6 over 2, 2 comma 1, and I simplified that to -3.
Mm-hmm.
And that was my x value, so I plugged that back in, and I got -3 to the power of 2.
Hold on. David's going to take over from here. So g of -3 equals?
-3 to the second
Mm-hmm.
plus 6 times -3 plus 5.
Okay. What'd you do first?
I did the, he gave me 9 plus 6 times -3 plus 5. But then he gave me 9 minus 18 plus 5.
Good. 9 minus 18 plus 5. Okay.
Then I subtracted 9 minus 18 give you -9.
Okay. Plus 5.
5 give you -4.
Yeah.
Now you put all together, you get -3, comma, -4.
Guys, clap it up for Salucci and David. All right. So,
Any question?
why is this helpful? Well, you remember all those charts we used to have to do? In 8.3, we can now graph quadratic functions without using a chart. I'm going to do one example with you guys, okay? And then we're going to call it for today, okay? So bear with me for one more example. What was that?
What happened to the test results?
Oh. All right. All right. So let's take a look at example 2, letter A. We have to identify the axis of symmetry of the vertex, graph it, and then find the domain and the range, okay? So let's start. We're going to do the exact same thing. Let's look at this function. Let's identify the axis of symmetry first and then the vertex. Matthew?
Alright, so to start off, you plug in -6. Wait, no, that is. Oh, wait, sorry. Then you put the, what is it called? The line, the dot?
A fraction bar?
Yeah.
Okay.
2
2.
times 3.
Okay. Matthew, I agree with you, but Matthew is forgetting one small but super important detail. Because if you forget this, you're going to get the whole question wrong, and it's only because you start off the problem on the wrong foot. What did Matthew forget?
Oh, I don't want to.
Natalie?
The B is negative.
The B needs to have another negative symbol. Matthew, did you remember that?
Yeah.
It's negative B over 2A. Okay? All right, keep going.
Wait. Doesn't it make it positive?
It does make it positive. So it's positive 6 over.
6.
What is 6 divided by 6?
1.
1. So what's my axis of symmetry, Matthew?
1.
Very good. All right, so Matthew found the axis of symmetry. I need someone else to take over to find the vertex.
The
Andrea, thank you.
So you plug in 1 for x, and then it should be the same for each one.
Mm-hmm.
So it should be 3, and then, okay, yeah.
Okay, so we plugged in 1. What do I get?
And then you get 3, 6, and then 5. And you add those.
Wait, did I miss something?
Yeah.
Is that a negative 6 there? Okay. That should be a negative 6. Good catch. All right, keep going.
And then you should get -3 plus 5, because it's -6.
Correct. Okay, negative 3 plus 5.
And then you get
2. Very good. What'd you say?
f of 1 equals
Good. So what's my vertex? 1, 2. Very good, Andrea. All right, so we have my axis of symmetry, my vertex. Hey, listen up. We have not touched on this yet. I told you that your y-intercept for a parabola in this form was 0, comma, your c value. So I know another point on my graph is 0, comma, 5.
You have 2 points.
0, comma, c. Please highlight that, guys. That we have not touched on yet. We need that point in order to make our full parabola, okay? All right, let's go ahead. Let's put each of our sections on our graph. Let's put the axis of symmetry of x equals 1 on my graph. Not yet. Okay, let me finish. How would I put an axis of symmetry of x equals 1 on my graph?
Put the thing on 1.
I put what on 1?
The dot.
A dot on 1? Which one? What's the axis of symmetry?
X equals 1.
Where did I get x equals 1? That was my axis of symmetry. Okay?
Put the dot on 1, but on x.
Oh, on the x one. So there's a dot here. The axis of symmetry is not a dot, guys. What is it?
It's a line.
It's not even just a line. It's a dotted line. It must be vertical or horizontal? Vertical. And it must go through x equals 1 for this case. Where was my vertex, peeps? What did Andreas solve for? 1, 2. So that tells me how high up on my axis of symmetry my vertex goes. And then what was the last point that I had? 0, 5. Where's 0, 5?
Facing down. Right there. And it's going down.
It is not facing down. Let's think about it. Look at your A value. Is my A value positive or negative? So that means my graph should be up. Check it out. You're going to start at the vertex and draw a curve going up. Why is the axis of symmetry so important? Think about the wording. Axis of symmetry. Shouldn't it be symmetrical?
Yeah.
So do you agree that that point was 1 unit to the left of my axis of symmetry?
1 unit to right.
So there should also be a point 1 unit to the right. So there should also be a point right here, and we're going to draw another part of our parabola facing that way. Wait, why what?
Why do you have to give 1 on the other side?
Well, remember, your axis of symmetry, right, Mia? It cuts your parabola directly in half so that it's symmetrical on both sides. So if there's a point right here, Mia, that's 1 unit to the left of your axis of symmetry, you have to flip that point over to the other side. So now I know there's also a point on the right-hand side. Okay? Did we use a single chart for graphing this one?
No.
No. So we're going to be able to do both methods, okay? If you're a chart person and you love charts, feel free to just use a chart and be able to figure out the vertex and the axis of symmetry, okay? But these problems do become a little bit more complicated, and you may not be able to create the best chart in the world, okay? All right, turn these in. Shoot. Domain is what?
ARN.
All real numbers.
And the domain is y less than 2.
Y is not less than or equal to 2.
Greater than 2.
Greater than or equal to 2, okay? Because look, Addison, at 2, it's all the values above 2. What?
You need to unlock this, please.
Oh, I need to unlock you?
Yes.
Where it has h of x equals 2x squared plus 4x plus 1. Does anyone remember? I know we did this a long time ago, but what do I do first? Salucci? Very good. Negative b over 2a is the formula for what? What am I finding when I say negative b over 2a?
Axis of symmetry.
Excellent, Caitlin. It's the AOS, your axis of symmetry. Make sure it's also what equals negative b over 2a?
X.
X equals, very good, Karen, okay? X equals negative b over 2a. Where is the b coming from? Good, the number in front of the x. Excellent. So this is my b value. So it's going to be negative what?
It's always the number before the X.
It's always the number before the x. What's the number before x squared represent? A. And what's the last number that's being added or subtracted? That's your c value, okay? So it's going to be negative what? 4 over? 2 times 2. Very good. What's 2 times 2?
4.
So this is negative 4 over 4. What's negative 4 over 4? Negative 1. Bingo. So I have my axis of symmetry. Is my unnecessary points lost on the quiz? Is my axis of symmetry negative 1? No. Thank you, Christian. It is x equals negative 1. Those of you that did not write x equals, you lost points that you did not need to lose, okay? All right, so on my graph, I'm going to go to x equals negative 1, draw a vertical line or a horizontal line? Vertical, because it's x equals negative 1, down negative 1, and I'm Gucci. I'm going to switch colors because, you know, I like to make things look very pretty, okay? What?
When are we going to go over the quiz?
Oh my goodness, Matthew. Okay, moving on. So what do I do once I have my axis of symmetry? Caitlin?
You look for the vertex.
Very good. I look for the vertex by doing what Karen said, by plugging it in. So I'm going to take h and I'm going to plug in what for x? Caden? Gucci, negative 1, okay? So it's h of negative 1 equals 2 times negative 1 squared plus 4 times negative 1 plus 1. What questions do we have on this step for finding the vertex? I have a question.
What's that in series?
Go back to the graph. I have a question for you guys. How do I already know something about my vertex?
It's gonna go down.
What do you mean it's going to go down?
It's gonna be upside down.
Oh, it's going to be upside down? Why is it going to be upside down?
Because negative.
That's negative.
What's negative? The axis of symmetry was negative, but that does not tell us whether it faces up or faces down. Mia has a very good point, though. Yeah?
It's gonna face up because your A is positive.
Excellent, Gabe. It is going to face up because my A value is positive. But I also want to know something else, guys. Like, where is my... I already know something about my vertex. What do I know about my vertex at this point? It's going to be on your axis of symmetry. But I don't know whether it's here, 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 or here. Do you guys agree? I don't know where on that line it's going to be. But I do know half of my answer. I know that it's going to be on this axis of symmetry. Very good, AJ. Okay? So what we're doing now in red is we're figuring out, okay, where on that line does it appear? Okay? That's why we're finding the second half of our coordinate, our y value. Okay? So when we plug it in, what do I do first in evaluating this expression? Michael?
The exponent.
Excellent. What do you get when you square negative 1?
Positive 1.
So it's 2 times 1 plus, what's 4 times negative 1?
Negative 1.
Negative 4, and then plus 1. This is going to be 2 times 1 is 2 plus negative 4, or minus, I'll just change that to minus 4. Minus 4, and then plus 1. What do I get here, peeps?
Negative 2 plus 1.
Negative 2 plus 1, which is?
Negative 1.
Negative 1. Guys, negative 1 is not my vertex. Remember, my vertex is a point. It has two values, an x value and a y value. What is my vertex? Michael? Negative 1, comma, negative 1. Excellente. I'll put a V there for vertex. All right, so now I know the height of my vertex is right here. Put a nice dot there. And the last thing, change colors again to make it look nice and pretty, is your last 2 points. AJ?
The first one is
0, comma C. And that is representing what intercept?
1.
My y-intercept. The C value is 1. So you are correct, Matthew. It would be 0, comma 1. What? Where did I get 0, comma C from? Oh, like 0, comma C, this part? Mia, that is something that's just traditional for all quadratics. Is that last value in your standard form, that C value, is going to be your y-intercept, okay? So that's just kind of something that we're going to have to know. Where's 0, comma 1? On the y-axis at 1. Very good. Now remember, think of the axis of symmetry as a mirror. If this is a mirror, right, and the blue dot was looking into the mirror, where would he see his reflection? Negative 2, comma 1 is another point. I have 3 points. I should know exactly what my graph is going to look like. Make sure it's curved, people. Some of you were drawing, oh, actually, this is a good example to draw what people were drawing on the quiz. Boom and boom. Guys, that's more of an absolute value function. Do you remember the absolute value function that looked like a V? Your parabola, what? Your parabola needs to make a distinct curve, okay? A distinct curve. Yes, go ahead. Caden? If it was a V, yes. It's a parabola. It needs to have a curve. It wasn't a significant amount, Caden, but I did take off points. 1 point? No, I think I took off 2. This example, what questions do we have? Natalie?
Oh, wait, never mind. I found out how.
You found out how? Okay, you're up.
I have a question.
What's up?
How do you know when, to the other side to get the last point?
The last point. So remember, David, that's why I drew my axis of symmetry. This blue point is 1 unit to the right of the axis of symmetry. Do you agree? So you have to move the same direction to the other side of your axis of symmetry, and that will give you the other point. So if we were to have a point over here, right, at 3, comma 6, it's how many spaces away from the axis of symmetry? 1, 2, 3, 4. Do you agree? So move 4 units to the other side. 1, 2, 3, 4. You would have another point over there.
I got to put the skips on the graph.
Correct. Absolutely. Okay, you can totally put the skips. All right, guys. You're going to work on C. We're going to compare at the end, but I want you to try to do it from start to finish, all on your own. Go. What do we do first? Christian? The fraction thing? Can we please use the proper vocabulary? Negative b over 2a, that fraction thingy. But what is it?
I don't know what it's called, but I call it the fraction thing.
It's not the fraction thingy, people.
Oh, it's the AOS.
It's the AOS, which stands for?
Fraction thingy.
Thank you, axis of symmetry. And it's not just the fraction thingy. What do I set equal to this, Mia? Thank you, it's x equals. Good answer, Mia. Okay. Now, what am I plugging in? Not 8. Negative 8 over 2 times 1. Because your a value is 1. So you're going to get, what's a negative 8? Positive 8 over 2. What's 8 over 2? 4. Did we get an axis of symmetry of 4? No. We got an axis of symmetry of? X equals 4. Thank you. So at x equals 4, we're going to draw a dotted line going up and down. Boom, 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 boom. Hold your question for the end, Mia. I promise I'll get to it, okay? Then we go ahead and work on our vertex. We plug in 4, so we're going to get k of 4. Colin. So k of 4 is going to be 4 squared minus 8 times 4 plus 7. What's 4 squared?
16.
So it should have been 16 minus, what's 8 times 4? 32 plus 7. What's 16 minus 32, Michael Salucci? Thank you. It's negative 16. And then when you add 7? Negative 9, peeps. The negatives make a difference. What's my vertex? 4 comma negative 9. That should have been all the way down here. Bingo. Then what's the last point I'm missing? Caden. Yeah, buddy. 0 comma C. In this case, it's 0 comma 7. 0 comma 7 is all the way up here. How many units away from the axis of symmetry is that point? Foe. So move foe in the other direction. 8 comma 7 is also a point. We Gucci? And then we draw our parabola. Make sure it's curved or straight lines, people. Curved, thank you. And should it be facing up? Look at the original problem. Should it be facing up?
Yes.
How do you know? There's no negative in front of your A value.
If it's 0, 7, how do you go that far?
What do you mean?
Like, why is it so far away from the line?
It can be very far away from the vertex because it depends on where your axis of symmetry is, right? Our axis of symmetry was 4, correct?
Yeah.
So your y-intercept is always going to be at 0, 0 comma something. So if x equals 4, it's 4 units to the right, then move an additional 4 and you'll get the other side. Okay? Mia.
I don't understand how you plug in the 2A for, just the 2.
Okay, what was your A value for this problem?
X squared.
No. Remember, the A value is the number in front of x squared. What number is in front of x squared? 1.
Oh.
So that's why our A value is 1.
Okay.
You got it? Good question. What other questions do we have? That's fine, okay? As long as it curves, I'm happy. I would not be happy with something like this, people. What? Why does yours always look like that, Caden? All right. No more questions? Min-max, baby, okay? So, we are finding maximum and minimum values. Now, the cool part, yeah, that's why I resent you the homework, because we didn't learn this yet, okay?
It was easy though.
All we're doing is we're using the exact same steps. Now, I need you to pay attention to this. Your maximum and your minimum values are your y values in your vertex, okay? So if you have your vertex, the y value will be your minimum or your maximum value. Now, you can only have one of these values for a parabola, okay? So there's 2 cases that we can have. Do you guys agree that we could have a parabola where our graph is facing our opening down and it looks like an N? Do you guys remember that? When does this happen? When your A value is negative. That creates what kind of point at the vertex? A maximum. It is the highest point, okay? It is the highest point at the vertex. Now, the reverse is also true. When do we get graphs where it looks like a U in terms of the parabola? When A is positive. So when A is greater than 0, we get a minimum value at the bottom of our parabola, okay? And we find the actual value by finding the value of the vertex, okay? The x and the y of the vertex. Now, a common misconception is that you're going to be like, okay, I know the maximum, and the maximum is at 3, 7. That would be considered wrong. All you care about for the maximum value is the y coordinate of your vertex. That will be your maximum or your minimum value. Okay? All right, let's check out some examples. So let's go ahead and look at A, B, and C. We're going to figure out whether it's a max or a min, and then find the exact value of that maximum or minimum. Okay? Now, if you're like me and you're a visual person, I literally have to draw a picture every single time. Otherwise, I don't know. Okay? So for letter A, I immediately look at what value will determine which way my graph is going to open.
Negative.
Your A. Is my A value a positive value or a negative value?
Negative.
So it's going to open down. I draw a picture. Do you have to draw a picture? No. Okay. I always draw a picture so I can visualize it. Now I'm like, okay, is my vertex now a maximum value or is it a minimum value? It's a maximum. So I'm going to write the word max next to it. Okay. Not as in like the name. It stands for maximum. And now I go about the exact same process I was doing because I need to figure out what my vertex is so I can get the y value of my vertex, and that will be my maximum value, the highest point my graph reaches. Okay? All right. So in order to get my vertex, what do I need to start with though? Axis of symmetry, x equals negative b over 2a. Very good. Okay? So, what's my b value? What's my b value? Negative 24. So, it's going to be negative 24 over 2 times negative 4. What? No. Not squared. Thank you. Okay, what's negative 24? Positive 24. Why? 2 negatives make a positive. They cancel each other out. What's 2 times negative 4? Negative 8. And what's 24 divided by negative 8? Negative 3. Very good. So what have I just found? Excellent. X is equal to negative 3. That's my axis of symmetry. That helps me, but it's not my answer. How does that help me? Now I know what to plug in because my vertex has to lie on that axis of symmetry. But I don't know how high or how low my vertex goes until I plug it in. So now we're going to do f of what value? Excellent. Negative 3 equals negative 4 times negative 3 squared minus 24 times negative 3 minus 19. We Gucci? Yay. Okay. What do I do first here? Exponents, very good. Caden, what's negative 3 squared? Thank you. So this is going to be negative 4 times 9 minus or plus? Why would it all of a sudden change to plus? Very good, Michael. It's going to be negative 24 times negative 3, which is going to give me a positive value. And it's positive 72 minus 19. Guys, what's 4 times 9? I knew that. It's negative 36 plus 72 minus 19. Let's go ahead and subtract 36 from 72. We should get 36 minus 19. 17. So what is my vertex? Negative 3, comma, 17. Guys, I already talked about this. Which of those two values do I care more about? The 17, the y value. This 17 is now, what did I say it was going to be? A maximum or a min? 17 is my maximum.
How do we write the answer for that? We just put 17 and circle it? Oh, okay.
That should be a y, my maximum. All right, guys, I know you're very antsy to ask me questions. What questions do we have? Mia, you blurted one out. Yes, go ahead. Where did the 17 come from? Someone else answer that. I was paying attention. Gabe?
36 minus 19.
36 minus 19 gave me 17.
Oh.
Okay? So when you evaluate the axis of symmetry, it's whatever that value is. What other questions? Talk to me. If I don't hear from anyone, that means that every single part of this entire problem made complete sense to everyone. Mia, what's up?
Where did the 72 go?
Where did the 72 go? So I combined the 72 and the negative 36. 72 minus 36 gave me positive 36, right? And then I subtracted 19 from it. David?
How do you know when you're going to have a maximum or minimum?
That's a great question. That all depended on what your A value was. In this case, my A value was less than 0. It was negative. That will always create a maximum, okay? Because your graph will be facing down.
Is your y always going to be the max?
Is my Y always going to be the max?
Because you wrote down that 17 is your max.
Where do you,
Wait,
what?
go down.
Oh, yes, this will always be your maximum. You're never going to use the x value for your maximum or your minimum, okay? What?
Like we know if we had X, like we changed the problem to problems and we plugged it in.
Mm-hmm. That was called system of equations. Mm-hmm. Similar.
I just got back at 5 this morning.
Okay, next problem. Let's take a look at letter B. First, determine whether it's a maximum or minimum. We determine that by looking at what value?
It's gonna be minimum.
The A value. In this case, my A value is positive or negative? A is bigger than 0, so it's going to look like this. I always draw a picture because I'm visual. And this creates a? This creates a minimum. Why?
Because it's positive and it's going up.
Because it's the lowest point on the graph.
Very good, Caitlin. It is the lowest point on the graph. Minimum. I'm clearly not an English major because I can't spell anything, okay? I put mini. It's a mini. It's a mini. Okay. What do I do next? I know I'm going to get a minimum, but how do I get it?
Fraction thing.
The fraction thingy. If you keep saying that, I'm going to lose my mind. AOS, thank you. Axis of symmetry, a.k.a., according to Christian, the fraction thingy. Andrea, do you know the formula? Negative b over 2a is half of it. Thank you. X equals. Very good, Andrea. Okay. All right, what's my b value, peeps? So it's negative 8 over...
Why do you put negative? Why don't you put positive?
Because I like to write out my steps step by step, David, so I don't mess anything up. What's 2 times a? What's a?
8.
2 times 8. So we're going to get, what's negative 8? Like David said, it's a positive 8 over 16. What is 8 over 16? Is it 2?
Yeah.
No. It's 1/2. Why does this one have to be a fraction? The denominator was larger, correct? Okay. Should we freak out because my axis of symmetry is a fraction?
Yes.
Maybe a little bit, but not too much, okay? All right. So we have x equals 1/2. What do I do with that value? Plug it in. So we're going to get g of, hold on, can you guys see that color?
Of course.
Not a good color or okay?
Maybe
Not a big yellow.
Use a different one.
It looks like purple.
I don't have purple. G of 1/2 equals,
I can't see that one.
G of 1/2 equals, let's go back. It's going to be 8 times 1/2 squared minus 8 times 1/2 plus 6.
Volleyball, please go to the girls' locker room at this time. Beach volleyball to the girls' locker room.
What do I do? Caitlin. Excellent. 1/2 squared is going to be 8 times 1 over 4 minus. What's half of 8? 4. Excellent. Plus 6. Now, what's the fourth of 8? 2. So this is going to be 2 minus 4 plus 6. What's 2 minus 4? Negative 2. And when you add 6 to it? 4. So what's my vertex first? 1/2 comma 4. And what's my minimum value?
4 is
Yay! We did it. What questions do we have on this one? Okay, we're going to do one more. Because we got to practice with our fraction. All right. Take it step by step. First off, what do I know about this function? It's going to be called... Michael, it's not actually that bad. What were you going to say, Christian? It's upside down. Why do you know it's upside down? It's a negative for the a value. That's the only one that we care about, okay? So, if it's facing down, max or min? Max. Very good, okay? So it's going to be a maximum. What do I do at this point? Christian?
Get the AOS or the fraction thing.
Thank you, the fraction thingy. AOS, x equals negative b over 2a. What is my b value?
negative. Just 3.
Positive 3, so it's going to be negative 3. Matthew, what's up? Yes, set a timer, please. Over 2 times negative 1 over 4. Those of you that are already like, I don't like this, you got to change your mindset, okay? What's negative 1/2?
The answer.
No.
2 times negative.
The denominator will definitely be negative 1/2, okay? So this is going to be negative 3 over. Do you guys agree that this 2 is 2 over? 1. Multiply straight across is going to be negative 2 over positive 4. You with me? What does negative 2 over 4 simplify to?
1, 2.
So it's negative 3 over negative 1 over 2. Hey now, what is a fraction bar? What operation does it symbolize? Division. So do you guys agree I can rewrite this as negative 3 divided by negative 1/2? Is that the same thing as what I just wrote? Okay. Negative 3 is a fraction over 1. How do we divide fractions?
Keep, change, flip.
Keep, change, flip. So keep the negative 3 over 1 the same. Change division to, and flip your fraction. So it's going to be 2 over negative 1. What's negative 3 times 2? And what's 1 times negative 1? What's negative 6 divided by negative 1? 6. What's my axis of symmetry? Don't you dare say 6.
X equals 6.
Thank you. X equals 6.
So this is like, wait, could you also,
Yeah, Karen?
could you also like just say from the fraction, divide 3 over negative 1, which would give you 3, and then multiply with the 2?
Yeah, totally. Okay, absolutely. Absolutely. Yeah, Caitlin. I already reset everyone's homework, so regardless of whether you were happy with your score, you have to go back in there and redo it, okay? But all your answers are saved, don't worry, okay? All right, and you should have done all your work, so it wouldn't be an issue. Okay, so what are we doing at that 6, peeps? Plug it in, plug it in. So we're going to take a h of 6 equals negative 1 over 4 times 6 squared plus 3 times 6 plus 1. Yes? What's 6 squared?
36.
So it's negative 1/4 times 36 plus, this is 18, correct? And then plus 1. What's 1/4 of 36? Not 8. It's 9. Very good. So it's negative 9 plus 18 plus 1. That's going to be 9 plus 1, which is 10. So my vertex is what? 6, 10. And what is my maximum value? My max is 10. Yay, we're done. Guys, that's 8.3. You have only one more lesson before the end of the chapter. How we feeling so far?